So here we are in college biology, and college biology is primarily a molecular biology class, which means we'll be spending a whole lot of time looking at the chemistry of cells that is undergone to keep us alive. That means we'll be spending a lot of time at the molecular and atomic level, which means we got to learn chemistry. So we're going to start at the basics of chemistry, elements and atoms. An element is any substance that is composed of identical atoms, and each element is defined by the number of protons of those identical atoms. So carbon, the element carbon, has 6 protons, and that means it will react a very specific way, and it has very specific properties, all defined by those 6 protons in each of those atoms. Oxygen has 8 protons, which means it has a different set of properties, and it will have different types of reactions because it has a different number of protons. But if you have a sample of carbon, every atom in that sample of carbon is identical with 6 protons. And if you have a sample of oxygen, every atom in that sample is identical with 8 protons. So elements, we got them. They are flavors of atoms, if you will. Now, the atoms themselves, what is an atom? Well, for a long time, atom was defined as the smallest particle that cannot be divided. But we have made advancements in physics and chemistry since then and know that that's not true. We can divide atoms. Atoms are made of smaller things. So we can't say it's the smallest particle anymore. But we feel good about the smallest particle phrase. The smallest particle seems like it should be right. And so we do have a definition where we can use the phrase smallest particle, and doing that sometimes makes us feel better. So an atom is the smallest particle that retains the properties of an element. So if you have that carbon atom, screw that. Let me go with a different example. If you have a block of iron, I think I've used this example before, but it's a pretty good example. If you got a block of iron, right? It's right here. I don't know if you can see it, but I'm imagining it. I can see a block of iron right there. It's a metal, so it's malleable. If you hit it hard enough, it'll bend, and it can conduct electricity, and it's got density. Maybe it's kind of heavy. So it has these properties. If I cut this block in half, and I have 2 rectangles of iron, well, this new rectangle of iron, it's still malleable, it still conducts electricity, and it has the same density. The properties of this element have not changed. And I can cut that into half again and have less and 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 less. And it will still have those properties. It will still be malleable. It will still conduct electricity. It will still have the same density. All the way down till we get to 1 atom. And when we have 1 atom of iron, it's still true. It still conducts electricity. It's still malleable. It still has the same density. But when we cut that atom, we start taking protons, neutrons, and electrons and separating them apart, it no longer has those properties. So the atom is the smallest particle that retains the properties of an element. So there we go. We've got elements and atoms. Now, as far as living things go, not all atoms, not all elements are created equally. There are some that are more important, there are some that are more involved, there are some that are more prevalent. The top 6 elements in living things all across our planet are in descending order of commonality. So starting with the most common and ending with the 6th common is carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Now, we're going to talk more about how each of those are used in living things and why they are the top 6 at a later date. But for now, know that carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, those are the 6 we're going to be focusing on. And those guys, the chemistry of those 6 are the ones we're going to care the most about. All right. I hope this helps. Struggle well.